Go ahead. So one of the challenges for kind of doing biomimicry is the fact that, as kind of what Matt mentioned, is that you have lots of different disciplines that come together, trying to come up with some kind of synergy that gives you a product that you might be able to make. All right. So one of the challenges that we have in doing biomimicry is the fact that, as a biologist, I have to talk to Don, who's an industrial design person, who may or may not know anything about the biology or the organisms that I'm talking about. Likewise, I have absolutely no concept of what it means to design something. Right? I haven't had the training to do that. What I have the training to do is to look at biology and discover biology, but translating that into something that deals with creativity is not my expertise. So the one thing I really like about biomimicry, and if you start adding a business into this, is that you have a chance to bring people together that have very different views of the world, right? With a goal of actually trying to come up with products that can potentially, one, make money, but also better humanity. All right. So one of the things that we had talked about when putting this together is, how would you actually go about taking a design person or an architect person or a computer scientist, a biologist, and come up with ideas that potentially lead to new products or new ways to think about things. So as Don had mentioned at the start, one of the things we talked about is, as an example, is what happens for disaster relief. All right, here's a situation where, if you think about it environmentally, there's some kind of disturbance, whether that's a hurricane, a tsunami, Superstorm Sandy, snowstorm, whatever. And then as humans, right, we have ways that we deal with that is based on kind of our social structure and our history of the way we've responded to change. So as a biologist, thinking, what do organisms do, all right, when they have to deal with environmental change? Because that's, in a sense, what they evolved to do. All right, and you can think about it as that, when you think about wildebeest, right, when the drought hits in the Serengeti, right, they just get up and move. Right? But that's not really a possibility for humans. All right? You can, if you look at the pictures, for example, after hurricanes come through, you see people standing in their homes that are destroyed. Right? They're not going to pick up and move and go someplace else. Right? And so the real issue becomes for us as humans is, how, if we can't move, how do we still maintain that social contact of getting restructured? And so what wildebeest do is that they've evolved over millions of years to deal with constantly moving. And the way they maintain their social structure is that social structure or social contact is maintained by always being in physical proximity. So one of the scariest things about dealing with disaster relief is that you have people from very different areas that all of a sudden are put together and forming new interaction. Right? And so what we can say, if you think about it as a response for me as a biologist, saying if I'm walking into disaster relief management, you think about it, is one of the things you might want to do is start grouping people based on where they actually live, because that gives them some kind of social support. Right? So that's one thing you could potentially think of. I could also say, well, maybe we should look to organisms that are always on the go. All right? So army ants are a fascinating system because they have no home. Right? There's no place you can stop and say, all right, this is the home of an army ant. All right, so they have divisions of labor. All right, everyone has a certain task. They even come together at the end of each night and create a temporary nest. All right? And the key for them is that there's effective communication through all those people that are moving around, and there's been a nice division of labor that lets them deal with change that's constantly. All right? If you think about human systems, most of us, the goal is at some point to settle down in one particular place. So as kind of a species, we're not really thinking about it always being on the move. All right? We're always kind of thinking about we want to be in one particular spot. But when a disaster hits, you have to mobilize all those people. Right? So one way to potentially do that might be to start assigning people different tasks, right, based on their strengths, to overcome doing something like that. I think that's not supposed to be next. One of the problems we have too is, how do you get people that have been displaced actually to a particular resource that they need, or how do you reconnect them with somebody else? So here's a picture of people standing outside the Superdome after Hurricane Katrina, and as you can see, it looks like it's a mess, and they're waiting to kind of find information about other people and then be transported to the basic resources that they need. So one of the biggest problems here is you have lots of individuals all requiring information, and how do we effectively get that information to them? Right? So if you take a look at ants again, harvester ants, they have a very similar system when you start thinking about it. So the way I think about this as a biologist is, I have a bunch of people that have to go through a narrow point. Right? And as they go through that narrow point, if you had people that were there picking up information, you can accumulate a lot of information really quick. Right? And so what researchers have been able to show is that if you look at the way that ants communicate, so you have millions of individuals in an ant nest, right? It turns out if you take these dots or individual ants, is you're going to see that there's very few dots that are brightly colored, and these are ants that have lots of interactions. Right? So if you look at that network, what you can see is that most ants don't have a lot of interaction with other ants. There's a few key individuals that, in a sense, are the conveyors of information to the rest of the nest. Right? So you can imagine here that as people are funneling through a certain point, is that you could have individuals that are collecting information from those people as they go through, putting that into a centralized system, and they actually become the ones kind of in the ant nest that allow this really quick flow of information across large groups of people. That's one potential way to think about it. Another thing that happens when you deal with the disaster relief is that you have to put individuals in a temporary situation, right? But sometimes that temporary situation comes into what Don would call protracted situation. So here's an example of a tent city that's in Haiti, still left over from the earthquake that occurred there, right? And so you need to think about that for humans. Nobody wants to live in a tent city. Nobody should have to live in a tent city. But they're in a kind of a difficult situation. Their homes have been destroyed. They may not have the resources to actually replace those homes, and this is where they're, in a sense, stuck. And so as a biologist thinking about this, if I look at organisms, you know, one person that has an issue, such as here's a cliff swallow in its nest, isn't a big deal. Right? 3 or 4 individuals that do this, you know, it's still not a big deal. But if you have hundreds of individuals that have to do that and have temporary housing, then you get something that in a sense is unstructured and very similar to what you might see in a tent city.
I think the average time a refugee spends in a camp is 17 to 18 years.
Right.
So what started off as a temporary housing situation
Right.
becomes...
Right. And to carry the corollary here is that cliff swallows build these nests basically for to rear their young, which is about 3 months, right? And then they abandon them. And the reason why they have to abandon those nests after a certain amount of time is that the number of parasites that accumulate because you have so many people together actually increases. Right? So but here again, this is a situation where you look to nature, organisms can just leave. That's not necessarily the case when we think about what we have to do as humans in society. And this can, go to extremes. So here's an example of Weaverbirds, and it starts out as a single nest, and then as you can see, they end up taking over the whole tree here, and all these are individual nests where colonies form. The point I'm trying to make here is that if you look at the parallels of biology, and look at what organisms do when they use resources, it's kind of willy-nilly and seems unordered. And in some ways, that's exactly what happens in tent cities and refugees camps. After a while, as the order breaks down, it resembles some natural systems. Okay. Hold on for a second. Now, one thing, let me back up. So one thing that Don suggested to me, is that how do we go from the protracted situation to actually thinking about a more permanent situation? Right? And this is an idea that I don't know if I'm comfortable with yet, and I can tell you why. And the idea here is that we have what's called a med cottage. Right? You can scale this up in thinking about having temporary housing for individuals. But the idea is to provide a permanent facility, that's similar to what we could say a typical home, but it's also temporary in the sense that it may only be there for a couple of years. Right? And so the idea here was to take a loved one or a relative, rather than sending them to a nursing home, right, would be to put them in a med cottage that would, in a sense, attach to your house or be on your property. Right? So if you kind of think about what we've done as humans, if we move from something that's very temporary, like a tent city, I can argue we can move into refugee camps and make something that's a little bit more permanent. And then we start thinking about what we do for loved ones and relatives, is we invest in something such as a med cottage as this. One of the things, though, to think about, and the corollary for me as a biologist thinking about change and thinking about disaster relief, is that we never really think about change. Right? We don't plan for change. And so I like to think about like this, is that here we have a tree, and a tree has to at some point produce leaves, at some point it has to flower and produce fruit, and at some point it has to survive some kind of environmental change, right? But the way that trees have evolved is that this change is actually part of their kind of design. Right? We, as humans, we don't necessarily think about doing that, right? The other thing that we have to think about doing that other organisms do quite well is how do we maintain mutually beneficial interactions across time? All right, so one of the great challenges in disaster relief is that you've taken people from a community where they've established those interactions, you've destroyed all those interactions, and then asked them to rebuild. It's actually very difficult to do. Organisms, all right, so this is an example of ants and acacia trees. Trees actually build resources or homes for ants. Ants live inside of these, and the benefit that they give the tree is that those ants protect the tree from basically being attacked by other insect herbivores, or in some cases even elephants. Okay. Plants and bacteria can form mutually beneficial interactions. What plants do is that bacteria starts out by, in a sense, infecting a root, all right, but that bacteria is also bringing in nutrients from the outside environment, and the plants provide this house for it in terms of a root nodule, and so there's this mutually beneficial interaction that happens. All right. So when you think about temporary structures, you think about protracted situations, or you think about caring for a loved one for long periods of time, the idea here is that nature has already inherently built in this idea of change. Right? That's not something that we continually do over and over again. Okay. All right. So I want to end a little bit here by thinking about this idea of what organisms do, at least to me, is that they can move. Right? But the problem is if we need to move people, how do we move people such that they can maintain social contact and physical proximity? Right? So to me, one of the great challenges for thinking about disaster relief or any kind of housing is, in a sense, how do you take a large number of individuals that are displaced, keep them in close physical proximity, because the social contact is what really drives human societies. Right? So for me as a biologist, it would be interesting to come up with potentially temporary structures that are somewhat ordered that allow us to keep doing all of that. All right, so I think I have one slide out of whack here. And I want to end by highlighting our Biomimicry challenge. Right? So one of the things that I'm particularly excited about is the fact that we get to bring together different disciplines at the challenge and also industry. And what we do there is try to facilitate this dialogue a little bit more. Is how do we make the connections between different disciplines and industry and come up with an idea. So this year, the Biomimicry Challenge 2, this is our second year. It's going to start on March 22nd and go through the 23rd. Right? And if you want to check out the website, it's syracusecoe.com. And as Don said earlier, we're still looking for potential sponsors. If you're a business person, if you're a student, or just a member of the community you're interested, you're welcome to attend as well. But our idea here is to generate interest, such in this way that Miriam has with NYSERDA, to get people to start talking about whether or not we can design new products and new services. So with that, I'll stop.
Great, thank you, Dave.